Let's look at problem 1, 2, 3, 4. Replace the substring for balanced string. So first, I will go over the statement of the problem, and then we will give a walkthrough of the examples, and lastly, we are going to write a solution using the standard two-pointer sliding window solution. So before we go into these steps, I want to make a remark. Actually, this problem is essentially the same as problem 76. So let's first look at the problem statement. So here we are given a string S of length n containing only 4 kinds of characters, Q, W, E, R. So a string is said to be balanced if each of its characters appearing 1/4 times n times, where n is the length of the string. So here we are required to return the minimal length of the substring that can be replaced with any other string of the same length to make S balanced. So if S is already balanced, we are going to return 0. So this is the statement. So the constraint of this problem is that the length of S is a multiple of 4. So the multiple of 4 is to make the problem valid, and also it can be as long as 10 to the power 5th. In other words, if we solve this problem using the square term complexity solution, some of the test cases might not be able to pass. So yeah, that's the statement at the constraint of this problem. So before we go to the examples, let me write down the method. So the method we are going to use is the standard two-pointer sliding window again. And so here the main idea is the same as Leetcode problem 76. So now the main point here might be how do we transform this problem into the format of problem 76. Before we do that, let's first look at the examples. So first is S equals W Q E R. So in this case, so each letter appears once. So this is balanced already. So as required by the problem, we're going to return 0. So another example is S is Q W E. Obviously, we see that the Q appears too often, right? So if we replace one Q by R, so we get a balanced substring according to the definition in this problem. So we are going to return 1. So we need to replace 1 Q to R to the corresponding one. So the third example is S equals QQ QW, right? So here Q again appears too often. There's no E and R. So we need to get two Q and replace them by E and R respectively. So in this case, we're going to return 2 as corresponding to 2 Qs. So it can be the first two, or can be the second and third one. So it doesn't matter. It does not matter. So the length is 2. So so now after reviewing these examples, we have some feeling about the problem. So now let me try directly go to the code, and then in the process we can make a comparison with the solution for Leetcode 76. So hopefully we can quickly realize they are actually the same. So first, a point to notice is that so we can first have the length of S. So in order for S to be balanced, our target is that each of the character should appear n/4 times, right? And also we will check how many times each letter has already appeared in S. So for this, let's initialize two dictionary. One is target, and the other is effect. So let's call it two dictionaries. And then, so we are going to check what's the current state. So for character in this four, that's the QWER. This is the four letters. So the target is this. The character, each of the characters appearing n/4 times, and the fact we have now is that so the time the character appears, right? So now the thing is that if a character appears too often, it means we need to replace them to the corresponding or to some corresponding characters which appear less than the supposed number. So we want to use a dictionary comprehension to record this fact. So this is a k and fact k minus target k. In other words, if a letter k appears too often, we need to replace it. So for k in this string QWER, the four characters, if fact minus target is greater than 0. So let's move a little bit here. So now we are in a good shape. So first aesthetic case is if not to change. So in other words, all the characters appearing as desired. So in this case, we return 0 as stated by the problem. So now let's first introduce a variable in order to prepare for the to-while loop sliding window. So that is the required how many characters are required to change. So this, let's call it required, which is the length of the dictionary. Now let's do the two-pointer sliding window. So we can initialize LR and formed. So it's 0, 0. Originally the formed is 0. The L and R are the two pointers, and the formed is to check if we have finished the changes for the required number of unique characters. So before we further go, so we want to check the condition using a dictionary in the process and the result. So here we are going to initialize it as a tuple in order to be able to print more meta information during the process. So because we are required to return the minimal length, we're going to initialize as float infinity. So here none, none. So this actually records the length, the start and the end for the window. So up to now, I guess maybe we have established a connection with problem 76. So now we are ready to run the standard sliding window algorithm. So let's see, well, R is less than N, the length of S. So we check the current character, so it's SR, right? Our goal is to find the minimum window of change, right? So now let's update the window. So character. So we try to window get. So we check if the current character is already in the window. Otherwise, we set it as 0. Then we update by +1. So now let's check if a character in to change. If this is one of the potential characters to change, then we will check if the change has achieved the desired frequency. That is, we check window character if it equals target. Window character equals to change character. If this is the case, so we will update the formed by adding 1, right? So now we are arriving at the step again, that is trying to push the left pointer L to the right. So while L is less or equal than R and formed equals required. So if this is the case, we are going to first check length. So if R minus L plus 1 is less than the result 0. So in other words, if we modify the window starting from L and ending at R, then we can make S balanced. So if this length is less than the preset length, that is result 0, we're going to update the results like this: R minus L plus 1 and L R. Right. So this is the update case. Then we move the window. So for convenience, we check the character L. So we move left. So when we move to the left to the right, in other words, we push L to the right. So the window, the corresponding character, decrease its frequency by 1. So now a critical step is to check if character in to change, and if it achieves the statement that the window the frequency of the character in the window is less than the to change for the current character. If this were the case, then formed should be decremented by 1, right? In other words, so this while loop will be exited. So yeah, after this logics, we are going to update the L by 1. So actually this L updated by 1, translating into plain English, it means pushing the left pointer to the right. Same here. So now as we exit this while loop, we are going to update our right pointer by 1. So now we finished the scan from the left to right, so we are ready to return the result. As required by the problem, we are going to return the length. That is the first component in 0. So for convenience, so we can also actually print out the result. So for example, print the result for more information. Let's check some cases. So we run the code for this case. So for this case, this already balanced, it should output 0. The output actually corresponding to infinity 99, so it just output 0. So now let's look at another one. So let's change this to QQWE, just so to speak. Then the output is 1, and the result is 1 and the window length, and it means it's with a start index 0 and ending index 0. It means if we change the window corresponding to the first Q, then we can make the string S balanced. So now let's test another one, which is WWQQW. So then let's check this. So the output is 2, and the standard out, that is the length, window length is 2, starting index 0 and ending index 1. It means that if we change the letter QQ to the corresponding proper ones, then we can make this length string S balanced. So with that examined, let's check the generic case. Let's comment out this print and then submit for the generic case. So yeah, it passes the test cases. That's it. Thank you.